Friends, welcome you all to the NPTEL open course on GPS surveying. Today is the first class which will be dealt with introduction to GPS surveying and its application. This class will be dealing with basics of surveying, then introduction to GPS and to introduction to surveying, GPS surveying and its application. Now what is surveying? Actually surveying is the science of measurements of the surface of the earth. In this what we do? We do find out the position of objects or points on the surface of the earth or near the surface of the earth. Why we do this thing? We do this thing to prepare a plan or map of the area. So let us suppose there is a area of which we want to prepare a plan or map. Now in this area there may be some road, there may be some telephone lines, there may be some trees, and there may be a garden or some river, etc. Now to prepare the plan and map of this area, we need to find out the location of these telephone lines, then the corner of this roads, then the boundary of this garden, location of these trees, again the bank of this river, etc. Now how we do this thing? This can be done simply by identifying some salient points for the objects to be identified, and from that points we can identify we can make these objects. How? Suppose I want to know where this tree is. So simply by knowing the location of this we can find out the tree. Now if I want to go for this side of this road, we can identify some salient points on this road, and joining these points we can get the side of this road. Or if we want to plot this garden, simply we will identify the salient corners, and joining these corners we will get this side, this corner, this side, joining these 2 points we can get this side and like this side. So and joining all these sides we can get the garden. That means what we can say, that whether the object is a point object or line object, object may be divided into this type: point object, line object and area object, and all these type of objects can ultimately be delineated or mapped by identifying salient points of the map of the object. So the whole of surveying involves in finding out the geospatial location of some salient points, and surveying is a very old engineering methods, and over the period of time there are so many instruments as well as methods has already been developed to geospatially locate the point. Now how do we locate a point? How can we locate a point? A point can be located, or a point gets located. Suppose a point P, suppose this is the tree point P. How can we locate? We locate it with respect to another point whose location is already known. In surveying this point whose location is already known, this is known as control point. That means known location. Now, with respect to known location of the control point, we will get the location of the point P if we know the distance between the point and the known point, suppose D, and also the direction of this line. Now, to know the direction, we need to have a reference and then we will get some direction. So, distance and direction of any point with respect to a point whose location is already known, we call it control point, or also we can call it as origin. Then only we will be able to get the position of the point P. Now, so this is the fundamentals how we go for measurement of, that means we have to measure distance and direction in normal conventional methods, and to measure the distance there are so many methods, just like tape, then EDM, electronic distance measuring instrument, then for angle we use theodolite, and there are some instruments which can measure both. Now, the distance is again there are two types, horizontal and vertical distance. Vertical distance we can measure using level. Then there are some methods like tachyometric method by which we can get both the distance and directions, or then we can go for total stations. But these methods provides us the location always with respect to some relative point. Moreover, these instruments and methods can only mostly work in daytime, and to work these instruments we need to have the intervisibility between the reference point and the observed point. Again, these methods can work only when the weather is favorable. So, the conventional methods have the limitations of intervisibility, and then where it is weather dependent, then it can only work in when the light is sufficient, daylight suppose. Now, and also these methods are very much labor intensive and time consuming, so these are not that economic. So, scientists and engineers are looking for some method which will be ubiquitous, means anytime it can be done, it should be versatile, it should be economic, and it should be easy, like that. And so with this objective there are so many instruments and methods are going on developing over the years. So it is the latest developed system which is scientists and engineers and surveyors want to apply or use in surveying is the global positioning system, GPS. Actually its full name is NavStar GPS. NavStar stands for Navigational Satellite for Timing and Ranging, and GPS means Global Positioning System. It is a radio navigation system, means it works in the radio range of the electromagnetic wave, and it is a all weather system, means it can work in all weather condition, whether it is sunny or rainy or fog is there. This system has been developed by US Department of Defense for military purpose. Later they have made it available for the civilian use. Now this GPS is that means signals from GPS is available to infinite numbers of concurrent users all over the world, all throughout a day and 365 days in a year. That means it is a ubiquitous system whose signal may be used by infinite numbers of users together in all over the world. Moreover, in this system the line of sight between the, suppose we want to find out the distance between this point and this point. So we do not need the intervisibility between this point and this point, because we will be getting signal from satellites, so it will reach both like this. So intervisibility between the stations or from the reference to the observed point is not required. As I told you, this works day and night, as well as it is also works in inclement weather. So the GPS system has overcome many limitations of the existing conventional surveying methods, and this has brought a paradigm shift in methods as well as instrumentation in the making measurements for land surveying. Now this picture will give you an idea how GPS signal arrives on the surface of the earth. Let us say this is a point where the signals are coming from some satellites. Now you can see at any instant of time, at any location, the numbers of satellites are different with time or with position. So and the idea is to get at least 4 satellite signals from at least 4 satellites will be coming to the station. Now GPS system provides the location in 3D. That means the location is given by GPS system either in Cartesian coordinate or in geodetic coordinate. So the position is Cartesian x, y, z or geodetic lambda phi h, latitude, longitude and height. So this is a big advantage over the conventional methods, where we get the position either the horizontal planimetric position or vertical position. Another advantage of this GPS system is that it provides the location, this location or this location in a global reference system. So we get the position always with respect to some fixed reference system. So it is an absolute location in comparison to relative location we get in case of conventional methods. And it works very simple, because in case of GPS, what we need to do, only we have to set up the instrument at the point of observation and signal will come from the satellite. We need not to do anything else, and later we have to download the data and process the software. So, set up the instrument, collect the data and then download the data and process the data. So, this work does not involve much of physical involvement, as well as it does very simply. So the method is very quick as well as simple to do and not labor intensive. So the surveying or GPS involvement will be economic, efficient, flexible, less time consuming in carrying out land surveying. And all these has brought a paradigm shift in the methods of land surveying, and thus the productivity of surveying using GPS will be much more than what we get in conventional method of surveying. Moreover, GPS receiver nowadays are widely available as well as it is economic, and there are many softwares available even in the open source it is available. So GPS is becoming very popular among the users and surveyors. Now as further this GPS system is getting modernized day by day, that means it is improving. So like let us for example, initially we used to get only one civil signals L1 and L2 having the restriction. Now at present we do get 3 civil signals like L1, L2C, L5. Not only the number of civil signals are increased, the power of this signal was much less than the power of the signal now we getting. That means now the signals are more readily available and the amount of measurement, quantity of information we can easily get. So this availability of good quality receivers economically as well as availability of softwares as well as reliability of better signals, and not only it is powerful and number, also nowadays this L5 signal is available inside building as well as underground. That means initially the signals were available when the sky is open, in open sky, but this restriction is also overcome in the present day GPS signals. So the GPS signal is now finding out to be more versatile. So as a result of this, our GPS surveying work becomes easy, more versatile, widely available and economic. As a result it is economic, and so it is going to replace many of the existing land surveying methods. Moreover, GPS is getting accepted very fast by the engineering surveyor community. As a result, GPS is being used for different types of surveying, including land surveying. It is becoming the primary instrument to make precise measurement. Specifically, whenever we are in need to go for measurement of position, or we want to go for navigation, or if we want to go for measurement of time, then GPS is a very good GPS system, provides position the accuracy of in positioning is, for horizontal positioning we can get very easily millimeter accuracy. So 1 sigma plus minus 1 millimeter, and the vertical accuracy 1 sigma plus minus 5 millimeter. So this is the kind of accuracy we can achieve easily using GPS system, and time we can achieve accuracy in time of the order of 10 to the power 12 minus 12 seconds. So GPS system is coming up very 1 sigma. So nowadays any work that involves the measurement of position, navigation and time, GPS is the best solution. Now regarding surveying, you see there are different types of surveying that is conducted over by different community. Like for land surveyor community, GPS is being used for land surveying. One of the premier application of GPS is for land surveying. Now how do we carry out the land surveying? The basic principle of land surveying is to working from whole to part. What is that? Now suppose there is a big area which we want to go for surveying. So to start with, first we should go for some very precise measured control points. This is called zero order, or this is called zero order or highest order, and its accuracy is of the order of 0.01 millimeter, 1 sigma. Now, so the network first has to be now once this primary network is there, then we go for some lower order network like this. So within this network again we may go for still lower order. So like that. So once this lowest order network has been done, then we go for surveying about some area, suppose like this. From here I can go for this, from here we can go for this, like that. So in that area, in that way we go carry out surveying. Now in the beginning GPS was being used to establish the highest order control points, but as GPS is coming up very easily, economically, and also it is widely available receivers. So now GPS is not only used for establishment of the secondary or tertiary control point, but also GPS nowadays is also easily used for surveying work and mapping work. Now next, land surveying. Not only that, nowadays GPS is being used to measure the baseline. Now what is baseline? It is the distance between two primary control points. Now suppose we want to measure the distance from Kashmir to Kanyakumari. Now this is involved thousands of kilometers. Earlier it was a proposition, it used to be a proposition near to impossible, but nowadays we can do it quite easily. Simply we have to set up two instruments, one at Kashmir station, another at Kanyakumari station, and between that we will take the observation of this Kanyakumari station, we will take the observation at Kashmir station, and we will take together these two observations when we can process it, and we can get the distance between two stations within means very quickly. So and also economically. So the this is called highest order baseline, that means AA order of the accuracy 0.1 parts per million. So apart from that, there are other surveyings like photogrammetric control surveying. What is that? Actually in photogrammetry we make use of some aerial photographs to get the features and objects on the surface of the earth, but in order to get the features and objects with their exact position, we need to first establish the congruency of the photograph with the land, and that is done by using control surveying, photogrammetric control surveying. And this was a very difficult proposition earlier. Nowadays using GPS we can do it quite easily and more accurately than it used to be done earlier. Then geophysical survey, GPS is also used in geophysical survey. What is that? Now in geophysics we do study about the deformation of the earth due to earthquake, volcano, like that, and then pre-seismic, post-seismic deformation, then inter-seismic deformation, volcanic time series, what is the growth of volcanic deformation. So all these are nowadays possible. Then there is a movement of crusts. So how these crusts move, what is the rate of movement. Then there are plates on which all continents are belonging. Now these plates are moving from each other. Now what is the rate of moving between the plates? Before GPS it was impossible to know what to do, how to know. Now with GPS now we can measure all these deformations, crustal deformations and all these things. Then another area which is very much GPS is coming up, that is called construction survey. Now in construction survey we have already prepared map of the construction site using AutoCAD, and by using the AutoCAD map and using GPS, the stacking operation which was very difficult to do earlier now can be done very easily, quickly and accurately using GPS. Now another area of survey which is being benefited by GPS and widely used by using GPS, that is hydrographic survey. In hydrographic survey generally buoy is used to find out the coastal variations of the water level, and that is being nicely or quite easily measured by using GPS. Now this is in short about what GPS can do, how GPS can be used in surveying, but the amount of use in GPS surveying depends on the imagination of the users. Any user, any project or any work which involves the measurement of or determination of or need the position or velocity or navigation or time measurement, there GPS can be used. So in short, we can say that the use of GPS or application of GPS or domain of application of GPS may vary with the imagination of the user. With this, I want to conclude this class. See you again for the next class, which will be held on GPS system. Thank you.